Let's pick up where we left off by testing our simulation. Let's jump up, reset simulation on .NET 1, make sure .import 1 is visualized and hit play. And you can now see them moving outside instead of inside. Not exactly as we want them to, but we're getting somewhere. Let's stop that and rewind again. Jump back inside our .NET. Let's examine our static objects. So we have the ground here. If we visualize that and we look at our collisions tab, let's click that and expand our window, we can visualize the collision guide. Now if we zoom out and hit W, we should be able to see through it. Let's just increase the uniform diffusions of the floor to 100 and double tap the back arrow. And on the bullet data tab, hit show guide geometry. And now we should see that we have a fairly good representation of our grid. As we can see, the blue lines are pretty close to the black lines of the actual object. So that should be good. Let's look at our network editor and find the other static object for the bounding box. Now, if you visualize this and we do the same, so let's go to the collisions tab, turn on the collision guide, and double tap the back arrow to make sure that it gets picked up correctly, and set uniform diffusions to 1. We can see that we have a fairly close representation as well. So in theory, that should be good. But because we're using packed geometry, we want to be using bullet data tab. And if we look at the collision geometry there, so let's turn off the volume collision guide, go to the bullet data tab and turn show guide geometry on there. Now we should see something else. So now if we hit W again, we can see that we have a blue box encapsulating our bounding box entirely. That's not what we want. And that's probably why the simulation doesn't quite know what to do. What we want to do is change the geometry representation of this bounding box from convex hull to concave. And what that does, if we hit W again and we can look through it, that basically assumes that this object is hollow, whereas otherwise it will treat it as a single block. So this is better. Let's try and simulate that again and see what happens this time. So let's make sure we visualize the output in our .NET, go up one level, reset the simulation again on the .NET 1, and visualize the .import. Let's hit W again, and let's see what happens if we press play. All right, so the buildings are now properly colliding with the edges. They are still very, very slidey, but we're getting closer and closer as we go. We have a few buildings tilting. Let's hit space G. But we're getting closer and closer. So let's just rewind that again and continue tweaking some settings. Let's jump back inside our .NET. Let's go to our floor object again and just make sure that we use bullet data for that one as well. Let's expand this top window a bit. On the RBD solver, let's turn off volume-based collision detection, go to bullet data, and turn that to, that should be fine. You can still see we have a pretty good blue representation of the actual shape. Let's have a closer look. Now let's just run the simulation in here and see what happens. Let's hit W again. It's not quite what we want. Let's just rewind. Let's expand the network editor again and find our buildings, so the RBD packed object 1. Now what we want to do is find the bullet data tab, and we want to check on show guide geometry. So we can now see that we have our buildings where the blue boxes are slightly smaller than the actual gray boxes. So the actual collision box that the solver is using is smaller than the actual building, and that might create a few issues. If we scroll down, there's this collision padding, and if we take off shrink collision geometry, we should see that the bounding boxes that are being used for collision detection are now the size of the buildings accurately. Let's rewind that and play again. So we can still see some jittering, but it's a bit less, and we can see our buildings escaping through the floor. We also have sleeping mode enabled, which we want to turn off. Let's stop that and rewind. So let's turn off sleeping. Let's also have a look at the settings on our pop solver. So we want to look at the update tab, and in here we define which forces to use. Now we don't need to integrate velocity or positions. And if we play again, it should look different. That's a lot more like it. Buildings are aligning to the roads nicely, and you can see that the simulation is a lot cleaner and more usable in our case. Let's have the block simulate to the final frame. So this is kind of what we can expect running these simulations on our blocks, and it pretty much works. So let's jump back up. So that's our dot import, and we have the actual bounding box of the block templated, so we can see that the buildings fit inside it precisely and align really neatly to the roads. This is exactly what we want. Now you'll remember that we had a lot of attributes on our points before we started simulating them. We want to make sure that we bring these attributes back on top of our points. So let's do that in the next clip.